Good morning, everybody. Thank you very much for joining us for this particular session. So our session this morning is, hopefully you're in the right room, energy infrastructure needs for achieving net zero. So my name is Sara Walker. I'm chair for the session today, and I'm just going to say a few words just to put a bit of context to the conversation before our three presentations, and we'll move to panel session with questions after those presentations. So I lead the National Centre for Energy Systems Integration, which is an EPSRC funded project looking at whole energy systems. And we've been established to think about issues around integration of energy systems in the UK to ensure that those systems are robust, secure, flexible and affordable. So we've been working in these work packages and developing, applying tools and understanding around energy systems integration to try and identify approaches that answer those quite difficult research questions around infrastructure, around risk, around uncertainty, around simulation, optimization, and we've also been looking at demonstrators. So in this space, in terms of energy systems integration then, we've seen from various different sources potential pictures of the future. And within those pictures of the future, we see quite different energy infrastructure to deliver that. So some of these future energy scenarios are around how does the end use of energy alter over time compared to our current 2020 picture. That's the graph on the left, 2020, and then a few different scenarios around how energy use changes in the residential, transport, industry and commercial sectors. But these scenarios and these changes are also quite different scenarios with regards the form that the energy comes in, or the energy vector, which is the graph on the right, which shows the change from 2020 and then 4 different scenarios for the future with different amounts of electricity, hydrogen, oil, blended gas, for example. So it looks, in order to achieve 2050 net zero targets, it looks like we need quite significant changes to our energy infrastructure. And even within that electricity box that was in the last slide, quite a significant change within the electricity sector in terms of where the electricity is generated and how that electricity is generated. And so in order to consider all these energy infrastructure futures and what we might need to do in order to achieve net zero, we've got a panel of speakers to present to you today. So my thanks to the speakers who are presenting and taking part in the panel. We'll hear from each panel member for around 10 to 15 minutes. And then if you want to post questions on the Glitter app, I've got the electronics to enable me to see what those questions are like coming through. And we'll have a panel session after the presentation. So please use the platform to post questions to the panel. I'll hand over to our first speaker, which is Malcolm Arthur from National Grid. Thank you.
Thank you. Yeah, so Malcolm Arthur, I work for the gas transmission and metering part of the business, and generally I'm going to tell you today we need a hydrogen infrastructure. Of course, that's what I would say. If my electricity colleagues were here, they'd say we need electricity infrastructure, and we probably need both. And, and they are quite complementary. But I'm going to talk mostly today about hydrogen. So this is the state of play today. So if you have a look on the left, we've got about 23 million gas customers, generally me and you in our homes. 85% of heating is natural gas today. Another big figure on this side there is 39% of the gas is used for power generation, and that's equivalent. So over 40% of electricity is currently gas-fired generation. And we got about 23% is industry. So there's a huge amount of energy. In the bottom here, you can see there's about 2.5 times as much energy transported through today's gas system than is the electricity system. Now, we know electricity is going to grow significantly, but how do we decarbonize gas? What is the point? How do we manage the decarbonization of gas, and how do we do that? You can see some different numbers here. There's 881 here, and there's 811 here. Generally, these numbers are from different years. And it just means there's a cold winter one year and not a cold winter another year. So it depends on the winters and the different numbers you get there. But it's about 850 terawatt hours. And what are we trying to achieve? What did the hydrogen strategy say, and what are we looking to do? So if you have a look at the very bottom of the graph here, we're looking to develop hydrogen, and it suggests from there that we're looking at about 250 to about 450 terawatt hours of hydrogen in 2050. So that's around about, I know it's not quite, but it's around about the size of the electricity demand today. Not quite, but you know, around that sort of number. About 20 to 35% of overall demand. And what they suggested they wanted to achieve in the hydrogen strategy was a dynamic, competitive, liquid, integrated and liquid market for hydrogen by the 2050s, or the late 2030s at the earliest. So what we are trying to achieve is probably very something similar to the electricity system and gas system of today. Today we have a very good gas market, very liquid gas market, one of the best in the world. Probably the second best if you measure it in Europe, with the TTF in the Netherlands being the best. And the electricity market is a relatively good market in the UK as well. So are we trying to replicate that hydrogen market of the future to what we have today? Could that look like? So this is our sort of vision of what you could do as a starting point for hydrogen infrastructure. So on the right-hand side, the light blue lines in GB is our current natural gas system. What we are looking to see if we can do is to carve up that natural gas system using existing assets to build a new hydrogen system. And in the first instance, how we would do that is to connect up the large industrial clusters that are around the country, to connect those up in the first instance, because they're the ones that seem to be moving quickest. So you can see Grangemouth, Teesside, Humberside, Merseyside, all those clusters could be connected together to provide them with a market, some resilience, and also connecting to storage, diversity of production and supplies. So that is the idea. Also, if you have a look, we are suggesting that you can connect to Bacton. Now, why Bacton is significant is because that's our interconnector into the EU, into Europe. We have a couple of interconnectors with the Netherlands and Belgium, and hopefully we'll be able to import and export hydrogen through Bacton, and maybe even through the LNG equivalents of the future at Grain and Milford Haven as well. So this is our vision. The vision is about 2,000 kilometres of existing pipe, around about, so about 25% of our existing network we would be able to carve up. And we would like to do this sometime in the near future, say near future in infrastructure terms, is in the sort of next 10 years. So we would like to see if we can do this in the next 10 years. And then once you have this backbone in place, the idea would be then, can you grow that backbone out to supply more local demands, more residential, maybe even home demands if hydrogen has a role in home heating, which will be decided in 2026 whether hydrogen has a role in home heating. So this is our vision of what a gas system could or should look like. What I would also say is that can you repurpose assets? Well, this is some of the work that we are doing. We'll go to in a minute. We are currently estimating about 70% of that network will be able to be repurposed. So it's repurposed pipelines, valves and such will be about 70%. So we'll have to renew about 20 to 30% of our network. So this is what we are doing to prove that we can put hydrogen in our assets. It looks like a bit of a dirty hole in the ground to some extent, which it is at this present moment. And we are building an offline facility using decommissioned existing gas assets. It's called Future Grid. You can look up the website. And on that site, at the very near end here, we are going to build a replica of a small replica of our network using different types of pipes and an entry and exit zone. And then we will pump different combinations of hydrogen through that pipe and then do some analysis to understand what impact that has. So we're looking to inject 2%, 10%, 20%, so we'll have a blend of natural gas and hydrogen. And then at some point in the future, have 100% in there as well to understand what impact that has. The one thing I would also point out on the right-hand side of this slide, we have a partner in Fluxys. Now, Fluxys is the gas TSO for Belgium, and they are also interested in this work, and they've made a contribution, so they are partnering us in this particular bit of work. A couple of things I would also point out. This is the hydrogen gas storage facility here, so the hydrogen stored in there. This is Northern Gas Network's distribution hydrogen grid. And at the very top here, very small, there are 3 houses where they simulate hydrogen gas leaks into those houses and then monitor how hydrogen disperses throughout the house to understand how to make hydrogen in homes safe. What do you need to do to make hydrogen in homes safe? I've been to those 3 homes. They've got monitors everywhere, and they've got these electronic openers for the windows, so when they release the gas, they can electronically open it rather than someone going in there and doing that, so they can do it a bit more safely. So there's quite a lot of work. And then in phase 2, this is phase 1, phase 2 is looking for funding currently, but we are going to convert all this area here, a kilometre pipeline with some additional facilities. So currently on this map, the blue is what we are looking to build now. So this is our funded point now, and then the bits at the top, the new bits, are the certain new ones we are looking to do. And some of the things we are going to be testing is something called deblending, where you inject 10% of hydrogen into the network, and then you see whether you can separate that out in a deblending way. Can you separate that 10% from that 90% into pure streams? And then can you purify it? And the reason you would purify it maybe is to use it in transport. Looking at storage and electrolyzers. So we are looking at expanding this into something a bit more, and then to understand how we can apply this to our networks, to also serve our customers' needs. Because of course, if we're injecting 10% hydrogen into the network and customers don't want 10% into the network and they're not interested in 10% hydrogen in the network, how do we manage that? So how does this link with other projects? There's another project called East Coast Hydrogen, which we've done in partnership with Northern Gas and Cadent. And this is looking at that sort of backbone we mentioned and then growing that out into industrial and commercial areas to understand how you could roll out hydrogen wider and into the local regional networks. So again, this has got a similar timeline to what we're looking at here, and we'll go into that in a minute. But there's another project called East Coast Hydrogen, which is looking at sort of more detail about how you then push that down into these sort of more regional areas. How does this connect to the rest of the world? Is anyone else doing this particular bit of work? Well, this is an example of what is happening. So we were partners to a European project looking at what a hydrogen network could look like in the EU and Europe. So you can see here that the sort of darker green colours are the existing repurposed network, and the yellow is new pipelines. Sweden seems to have an ambition to have a significantly new hydrogen network, by the looks of it. We are looking to repurpose significant parts of ours, and you can see in Belgium, Netherlands and Germany there's quite a high ambition to have quite a robust hydrogen network. Again, this is a vision done by the networks itself, but this is what they're sort of looking at trying to produce across Europe. The dotted lines, as you can see, between ourselves and Belgium and the Netherlands, that's our interconnectors, our UK and BBL, looking into Europe. Hopefully then that means we can import and export hydrogen across those interconnectors. I mean, generally we have really good wind resources in the UK, so we have the ability to produce green hydrogen and therefore potential to export green hydrogen into Europe. Timescales, so that's our vision. I mean, that's what we'd like to do, but there's a lot more work to get that to actually physically do in the project itself. So where are we? We're looking at a sort of feasibility study starting soon with the hope that we can get sort of feed studies in the mid-2020s, and then we'd like to start building this in 2026, 2027. So that's our ambition and aim. What we need, of course, is approval from government, approval from the regulator, and also our customers that they want to do this. So this is our vision, but what we need to work on over the next few months is customers, regulation, government, and how we fund that. That's it. Thank you very much.
So our next panel session speaker is Vandad Hamidi. Straight over to you.
Yeah. Good morning. I'm Vandad Hamidi. So I work for Vinci Energy's transmission distribution. So I'll explain what Vinci is. If you haven't heard of us, we've probably seen the logo of Vinci on a HS2 project in the UK more than anywhere else. But effectively, we're a large contractor, global contractor. In terms of the actual size, we're the second largest after Bechtel. That's what effectively we're known for. There are two parts of the group. There's the concessions business, which is very much interested into investing in any infrastructure that gives you a high return. So if you fly from Gatwick Airport, Belfast, you probably have paid some fee to Vinci as part of your landing fee. But trying to get them interested into more of an energy infrastructures, which actually getting some momentum. But then the fun part really is with the contracting, where we actually come as a effectively turnkey PC contractor, take on a project and build everything for a customer. So instead of just showing you a very fancy project, sorry, slides, this is the real part of our work. Muddy, brownwood contractor, getting to snow in Caradale. So that was actually last December, where we started applying the snow for our customers. And really, that's what the real work is for us. I don't get to wear a suit all the time in these days, but yeah, it's always good to be in these sessions. So the day-to-day work, for a contractor is very much, as I said, to be site-based. At best, we can do some engineering up front, and then, take on a solution to actually build it. Our focus is very much into T&D sites, so working for distribution companies, transmission companies, offshore wind developers. So we build everything from generation all the way into the distribution side. Heavily, as I said, focused on the transmission assets. So the picture you can see on the right-hand side is you may have about a smart valve. So they're effectively back-to-back converters that actually National Grid is now putting on the network to release grid capacity. So that's a site in Penwortham. And then on the left-hand side, it's a brand new substation for SSE in Kintore. So it's going to be effectively a first SF6-free switchgear substation that actually we're building for them. But what we are interested in terms of the future of energy grid and what it really matters to us, because technically we can be very reactive and sit back and wait for a customer to come to us and say we need this in a solution. Obviously, as a contractor, it's there's a two-way to approach things. One is to actually wait and see that invitation to tender comes in, and then build up that scale, and then go and actually try and offer it. We see more and more these days that could be a part of that solution for the customer. So we get involved at the earliest stage at what's known as early contracting involvement. So we define that solution for end customer that should say, you need to actually have this, for example, this type of infrastructure. Hence, there's a lot of interest in terms of how the whole kind of energy market is changing, what's happening to it now. And I think this is just a few things to give you a flavor of how we see things in terms of the generation, energy delivery, but also in terms of capacity of the transfer of the energy into the grid. I'm sure you've heard about inertia fault level issues, heard about sort of backflow that actually keep changing the grid. Issue with embedded generators, and we see that quite a lot. So we go and commission a protection solution for the customer. That doesn't work. It used to work 10 years ago. We see why, because it's to do with embedded generator rock-off issue. So we have to change that. A lot of obviously focus on the generation solution that actually customers come to us initially with what they feel as a bankable project, but then we do some engineering, they go and do the numbers. Oh, actually, no, I can't really make money at this market now, so this battery project doesn't really work for me. So there's a lot of it on the energy side that actually, we're interested to help them to say, yeah, you may want to have extra revenue stream, to make your project bankable. But then as the grid is changing, again, we have to sort of try and align with our solution with, the change in the grid, and just give you one case study in terms of what will happen when the grid becomes weaker. So the change from, synchronous generator to non-synchronous. So when you lose coal and gas plant and you have more wind, solar in the grid, so it effectively reduces some grid parameters like inertia and fault level. So that's actually something that we're seeing quite a lot in our project where it has a huge impact. One example was we actually were commissioning a effectively electrical grade equipment in the grid called shunt reactor. So very simple, very static, no problem with that. And the shunt capacitor together. So anyone a wind farm in around like in southwest Scotland. Back in 2011, obviously we had a number of thermal plants in that area. We had a very strong grid. So we had Cockenzie, we had Longanet, and quite a few other plants in the area. We saw obviously when you energize a grid that your asset, you get a steady basically change in the voltage and things seem to be stable. So your capacitor is switched in, your voltage goes up and everything fine. So it's still a bit of noise, not an issue. Back in early January, we were recommissioning in the same asset, no change in anything. What just happened back then was, you can see, there's much more wind farm in that part of the grid. We've lost 2 big thermal plants. We lost Cockenzie, we lost Longanet, and Tornus wasn't actually operating, so one machine was actually out. We see the same asset being effectively switched in, and that was the impact on the grid. So all of a sudden, huge oscillations. And we actually thought there's something wrong with our asset that actually commissioned for a customer. Whereas actually not really. That part of the grid is now very much heavily dominated by effective power electronics. So it's no longer, you don't get a backbone of like a stable grid to actually be able to work with. And that's just one example of how when we go to energy transition, what happens to the grid and what the potential issues are. Looking forward, really, if you look at the past, say, what's happened in the past 10 years, we can see the same decline of, things like system inertia on the grid. This is all forecasted, and what is replacing it is actually very small, so compared to what we are losing. So we lost about probably, excess of at least, 180 GVA seconds of inertia of the grid. We've just got maybe in the last probably 12 months, maximum 12 out of, all this pathway in the project. So that's definitely like, means, something else needs to be done. We obviously can see ourselves in a situation where a lot of the technologies that are coming in to making money out of the grid services won't even be able to function well. So fast-acting fixed response actually could destabilize the grid in a really weak system. We see that quite a lot now in some of the project now. So actually sometimes they have to be effectively curtailed just because of that. Sort of quite an important point on grid access. There's assumption where if you're a developer, you can connect to the grid whenever you want, as long as you pay for it. In reality, it's not the case at all. So there are people behind the queue quite a lot. So if you have got a solution like, for example, I want to build a synchronous compensator, I've made my project bankable, I've got a battery project. You're long behind the queue, so there's a huge competition for grid access at the moment to offer this solution. So, which means, if you don't think about your solution right at the beginning and come back, saying, 5 years later, you potentially can't even have a grid access. So, yeah, you may get a connection through connection offer, connect and manage, but actually, in reality, that solution is no longer helping the grid as much as it should do. And I think the last one, which is hopefully affecting us quite a lot, is supply chain. So, I can say that this is not easy time for contractors to win projects now, because there's so many opportunities in the market, and actually we just don't have capacity to address all of them. It's almost like a contracting market now, where we used to try really hard to win a project. The projects are there, but actually we are reaching our capacity to actually deliver all of those. Often, as a contractor, you have to turn down projects and say, we can't really do this. So I think looking at the rate of developing the grid, what needs to happen, I don't think we've built enough capacity in our supply chain capacity to actually be able to address all of that. So one example I can give you, if you look at the solution that you actually have for building a typical substation, you only have 3 effectively manufacturers in the grid at the moment that can give you a, say, protection solution. There is no 4th one. We actually have not managed to bring on a 4th one to the grid, into the market now. So you're limited by what they can do. So your project is staying often behind just because of that. And I think there's the other piece with that is, you can define a project at the moment by just addressing one need. So you're connecting a wind farm, you build one small substation for it, or one piece of cable overhead line. You can look into what's going to happen, say, 5 years later, 10 years later, and is it best for me to actually, whilst I'm on site, to actually give you an extra bay each side of it as a spare for the future. We see a lot of that happening in Sweden, in Denmark, where we build a substation for them, and there's always in the future, oh, look, okay, yeah, I just need 2 bay now, but let's build 6 because I'm going to connect some more in the future anyway. And it's cheaper now to actually, have that future sort of, view in terms of what needs to be done. Whereas we find this quite a lot, our customers are very restricted about what they can effectively, claim back, hence, over time, over 10 years, you probably find that actually you paid often times and half rather than what you would have been paid for, the actual cost of, future grid development. Again, what we feel actually, again, from a contractor side, what needs to happen, obviously there are various things in terms of the making your market viable for, if you're a wind developer, solar developer, to actually want to add some, extra capability to your solution, add some battery, just do it at the earliest stage, because actually that will be cheaper for end customer rather than come back to 2 years later. It's always adding something will become more expensive, and we see that. There's an element around what we see in terms of holistic network and generation development, where the grid companies will look into what we call a best view. So yeah, we've got all this contracted background of the different scenarios, but the best view is what they actually will end up investing on. I think that base view needs to be a little bit better defined, because we find that a lot of times the project gets put on hold and then becomes more expensive down the line, just because actually one generator decided not to actually connect at the right time. I think there's an element around it's not just about large wind, large nuclear, large offshore wind. We've seen probably more embedded solar PV in the grid in the past 10 years than we've seen large offshore wind. So there's an argument around actually, are we just focusing too much on larger generating, larger assets, or no, actually should be a lot more focused on distributed assets that actually have potentially bigger supply chain as well. On the network side, I think unlocking that grid capacity, so we can't just build new infrastructures. There needs to be a focus on actually, can we get more out of the existing asset? Are there solutions that actually can help us to actually release a bit more, maybe 200 megawatt, 100 megawatt here and there? That will still help, to actually help move towards, decarbonizing the grid. And I think at the end, really, we see quite a lot in Germany, especially, where every time we work with 10 or 50 Hz, especially, the 2 TSOs are very much focused on developing energy hubs. So that means they just say, yeah, I'll need 3 or 4 substations, actually overall build one super biggest substation in this area, and actually potentially help me to connect more and more assets, help with my grid resilience. We see less of that type of thing in the UK. I think it's probably been discussed in the context of large offshore wind projects, until round 4 onwards. But there's a clear reason for actually find yourself that actually becomes much cheaper and much more efficient grid development if you actually have those more of a holistic energy hub model rather than here and one at a time. Just again, one simple example to give you. You may have about this smart valve technologies. It's one of the example of grid flexibility, where they're not essentially releasing any extra capacity, just help to direct the flow in the grid. So these are the technologies that actually I think Scottish Power initially explored as part of the innovation project. Now National Grid is deploying it to the grid. So all they do effectively, they work like a quad booster transformer, very similar to that actually help to direct the flow. And then if you've got a power corridor, that actually one is effectively overloaded, actually you can shift the power to the other one. So these are the solutions we need to see more and more in the grid, going forward to actually help in utilizing the existing assets. And I suppose the last point, where again, in terms of being a contractor engineering company, is the skills. So it's not just about, as I said, technologies and solutions, and all of that needs people. And I can't stress how, I suppose, desperate we are in this industry for right people. Our people are going to where? To say rail projects, to airport projects, to actually, sectors where actually we are competing with them. So, they say, hey, why should I stay here where projects come in drip feed to us? We go back to the banking sector even. So there needs to be a real thing, push to, get proper attraction to this industry to other people, to actually say, hey, come and join us, stay with us. And that's not just a case of, us training them, and actually need to be probably much earlier in the schools, at universities, and also type of skills. Back in the days, you just want someone to do a power system engineer to do power system study, but actually nowadays you want to have someone who can do, say, programming, digital engineering. Those are the skills that actually we really need now to actually be able to, do a quick design, efficient design. So that's, I suppose, the last point, in terms of our perspective. That's it. Right.
Thank you, and thanks everybody who's been sending questions through. So I'll ask our panel to come and take a seat at the front. Forgive me if I reword your questions slightly in order to ensure that the question is relevant to all three panel members and not just one. But I'll start with a question around skills, because it was mentioned by Vandad in the last slide there. What are the specific skills needs for this energy infrastructure change? And do we have enough people with those skills in either hydrogen, electricity, or the green finance sector? So I'll maybe start with Malcolm.
This way, okay, thank you. Yeah, so I've been an engineer for about 30-something years, and we've talked about skills and STEM subjects and lack of people doing them for that long. And I don't think we've addressed that, particularly in the 30 years that I've been here. I know we've got new skills now coming through, digital skills, AI, and all the other sort of new stuff. I don't think we're addressing that. I don't think we're focusing on that. And I don't know how we do it, because we've not been successful in the last 30-something years. So I don't know what a new policy is needed. But there is a significant skills shortage coming up. National Grid did a report, I think, about a year ago, 18 months ago. It's difficult to gauge time in the COVID times, but it was about 2 years ago. And in there, they said, I think it was about 450,000 new green jobs are needed by 2050. Now, a number of them were new, and a number of them were replacement, but it was a significant amount of new green jobs that were needed, not just, of course, in engineering, but across the industry itself. And when I look across National Grid, there's an awful lot of people like me who will probably be retiring, or I hope to be retiring in the next 10 years. And how do you replace those people? So I think there is definitely a skills shortage. I would love to have the answer, but we seem to have not developed that answer over my lifetime in engineering. So I don't know how we do that. But definitely, I think this is a big issue. The one thing we were talking about earlier as well, just to put some numbers out there, there's 20,000 houses a week that need to be upgraded in order to deliver net zero. So that's 26, 27 million homes need to be improved in order to get zero carbon heating and other things in their homes. And so that's 20,000 a week between now and 2050. So that's 1 every 2 minutes that we need to convert. And we were talking about the skills in order to do that. Now, if you need someone to come in and do installation in your homes or change your heating system, it's really hard to find people to do that. And when we need 1 every 2 minutes, there isn't enough of those type of people doing that work. Now, whatever we call them, whether they're engineers or whatever, it's not enough people doing those core skills as well. It's not just people in the offices or doing the sort of designing of the system. There's also that in the jobs. And that's also a great leveling up agenda, because these people are not people that are centralized. These are people who work across all the country in all different communities. So there's definitely a lack of skills. I haven't got the answer.
Kirsty, do you want to say something about skills?
I'm one of those people with a house that needs renovated, so I'd just like to reinforce the comment that was. I mean, I don't really have a huge amount to add, other than I think it, as part of an industrial strategy that we, to be honest, haven't had for a long time, that would need to be a core part of that, as well as some of the other factors about supply chain. Because, you know, in the Infrastructure Investor Summit that I was at, you know, skills and recruitment are core issues as well. So right across the board.
Vandad?
Yeah, I think just to add to this, really, what we used to solve the solution of lack of a skill, at least in the engineering part, by, you know, playing tricks of offshore design centers, for example. That was like one of the really common thing, you know, we used to do. Looking ahead, even at the moment, you know, we can't get attraction from, say, you know, design centers, say, in India, in Bangladesh, in Egypt, or actually, you know, because they've got enough work there. It's a global, effectively, demand for skill. And I think creating it in-house, actually, in the UK is even ever more important. And actually, as you know, Malcolm said, yeah, sometimes there's certain things you can do remotely. You can't just have to go back office places. Actually, you need front hand, actually, someone that can do it, and a damn thing needs to be done. So, I think in terms of specific one, really multi-skilled, really. You know, we can't just actually train someone just to do one thing. But as an engineer, as you know, a site-based stuff, we need multi-skilled actually people who actually can do multiple things, because that's how the market is evolving. And making attractive for the people. You know, thankfully, I can see now engineering, people now earning much more. So what used to be very steady, 3% year on year, now actually engineers come to us and say, no, I want like, say, 20% pay rise every year. And that's good on them. And I think that's really good to see that actually that at least, we are now seeing as a good, effectively attractive industry that actually can actually, and we have to do it to actually retain them. So, yeah.
Great, thank you. And so another question, related, I think, but I'm going to word it slightly differently from the audience. So there's the opportunity to develop locally versus nationally and internationally in terms of energy infrastructure. And that has opportunity to contribute to the economic prospects of local areas. So what role do you see for national and or local governments to ensure infrastructure is developed locally as well as nationally in order to deliver that better quality of life? And I'll maybe come to you first, Kirsty, because you'd mentioned municipalities as an area for investment funds.
One of the questions that I'm always, often wondering in the debate, and really vibrant debate about city level and regional level rollout of climate solutions is are we clear about some of the jurisdictional issues? So what is under the purview of local government to make decisions on, and what is under the purview of national government? Same with devolved administration, so that we can really sort of home in on what those roles are, because I think they're very important. I mean, I think some of the most dynamic issues, particularly if I'm going to be not to just talk about the UK, but where there's blockages in national government action on climate, often it's municipalities and local or regional, or in the US state governments that are able to move fast and further forward. And it's just getting those jurisdictional issues so you can see who's responsible for what decisions, and then that's nice and clear if you're going to move in and take action. And there's also peer-to-peer stuff. I remember there was quite a lot of conversation about local, completely fully distributed sort of energy takeover from the suppliers. So there's all sorts of things that can happen that maybe are sort of even within that boundary.
Vandad, maybe.
Yeah, I think coordination role probably would be more important in that arena. I mean, some of that is happening already. I mean, look at the network side. You've got, for example, private networks and private wire networks. So to a certain degree, they're providing energy solution locally. But it's not, the coordination like local network, companies or local like energy developers, and actually what happened again nationally, I think, would be quite important. So in that world.
I think you need a national framework to say this is the boundaries for which you need to make decisions, and then those decisions need to be more local. So I mean, most of us like decisions in our area made by more local rather than a national organisation. But the people, going back to skills, the people in the local and regional areas need to have the right skills in order to do that. I mean, infrastructure, connecting gas, water, electricity, digital is all quite complicated, and how it works together is quite complicated. So you need the right skills in order to do that, and you need the companies in order to feed that in. So I think that there's a national framework that's needed, but going back to Kirsty's point, I think you need to make sure you know who's making the decisions in your area, and then they can make those right decisions. Maybe right is an interesting word, isn't it? It might be right for me, may not be right for you. So I think that's important. And then again, going to a regional point, if someone's decided district heating network's right, and then right next door someone's decided hydrogen's right. Yeah. And right next door someone's gone for electricity, that may not be the best decision for overall. So it's how do you coordinate that decision in order to make sure that you make the right decision over a wider area. I think it's incredibly difficult though, because currently we do not have the setup to do that in the country. We have very local areas, or we have national, but we don't have those sort of people making decisions on that area. And I haven't got the answer to it, but I think that's something that's come out a bit recently in certain consultations, but I think it's something that needs to be decided.
Okay, so no clear answers, but yeah, an interesting tension there. So another question on our transition. So given the urgency of climate change, what do you think are low and no regret actions we can take now for our energy system transition? And how do we ensure that those early actions don't close off later options into the future. So what early actions could we take? Malcolm?
Easy answer is use less. So I think insulating our homes and using less energy has got to be the right answer in the first instance. I think that's easy enough to decide, and I don't think there's a no regrets or a very, very low regret solution there. How we do that and how we decide to insulate our homes and how much intrusion we take as an answer, but I think that's absolutely no regrets. And then there's a number of maybe other bits. I mean, what's being talked about is off-gas grid homes, making decisions on them pretty easy now because we're not going to connect them up to gas, I assume. So maybe make those decisions today that we are going to focus on. I think it's maybe 15%. We can start to convert those homes today and change those into low carbon. So I think there's a number of low regrets that you can do today. But the easiest way, use less, I think, is my answer.
Great.
I think if you look at future energy scenarios, there's a clear indication that your peak demand is going to increase. So based on that, you look at your capacity of your grid and maybe some upfront investment and in the grid infrastructure. And even if you don't have that, exact developer connection at the time, that will actually potentially come. It won't be a regret. It won't be actually extra cost because actually you recoup that actually saving, at a later stage by having the upfront investment in your infrastructure in the grid.
Well, I think I want to approach this slightly differently, which is, I think we're beyond no regrets, aren't we? I mean, we've probably got one decision-making cycle on energy, which probably takes 4 or 5 years, and then we're most of the way to 2030. And so I think all of the things that we know we've got to do, we have to get on with. I'm not a big fan, personally, of all of the above. I think we need to push on renewables. We've not finished that journey, including distributed end and business end. We've not finished that journey. We've got to sort the networks out. I mean, that is absolutely clear. The 10-year delay, that is an obvious matter that needs dealt with urgently. And then we've got to be collectively working in the meantime on some of the intersectional issues. And, on energy efficiency, I mean, we have to be able to ask the question, when energy efficiency and demand reduction has been known about for 30 years. I did my first contract after university in New Zealand, as it happened, in 1989 on the avoided cost of electricity generation curves. I didn't do them, I hasten to add, I just collected them and put them into a report. That was already 10 years old. Everyone knew in 1989 why energy efficiency wasn't happening. And part of it is to do with, open question, is it to do with the supply industry? I mean, the business model. Because we can't have individuals competing with our suppliers, especially with really high standing charges, to do all the work to retrofit your property. With business, it's probably going to be different. I mean, there will be an increasing, I'm absolutely sure that wave is going to start. But I think we've got to have a more, I don't stick the, I can't think of a touchy-feely metaphor for getting really underneath why we have not been able to deliver on demand reduction. And I'm not sure it's just a question of optimizing through technology. I think we've got to go in and actually create the incentives and do the work to get the infrastructure changes at property and other levels happening. Because otherwise it won't happen. If we don't approach it in a determined, systematic, area-by-area way, I don't think we can deliver a house every 2 minutes.
Great. Okay. So I'll maybe come to Vandad first on this question, but to all of the panel. What's your take on storage? What capacity do we need in our future systems? And what kind of purpose will that storage have? Why do we need storage? How much and why?
How much? I think I'll leave that for people to go and read the future scenarios. But so looking back, what the storage actually initially came in, there was a issue about the balancing and arbitrage. People said it doesn't make sense. Actually, definitely, it's not cost effective. Economics doesn't make sense. But then we saw the storage coming in through balancing services for grid services. We had the first wave of a storage project in the UK through EFR tender, Enhanced Flexible Response for National Grid. Then things change now. They're looking to long-term storage now. So I think it's all about flexibility. I think that's what it provides, as well as helping to effectively stabilize the grid to a certain degree. So we need more flexibility going forward, and that storage actually does help. It doesn't just have to be in battery. There are many different forms of storage, and we should look at that. So yeah, it's all about flexibility, the main requirement going forward.
Thanks. And Malcolm, what about hydrogen storage?
I think there's a number in FES, and I can't remember that number, some terawatt hours. There's a number of different numbers in there. But going back to what's been said, so I agree, flexibility is the big issue. So, and I guess it's what purpose is it solving? Is it doing short-term storage within day fluctuations, or is it longer seasonal storage? So I think storage is a vital part of having a solid, secure system. Beyond it is today, but that storage is being done. You mentioned inertia and other bits is being done in other ways previously, but we need new storage to do that. So hydrogen storage is definitely an option, and we have the capabilities and the structures to do that in this country, and we just need to connect that up. So we can do that, but again, going to the point, we need to start to look at it. I think storage is an interesting one. So you've got the flexibility, you've got that within day or maybe seasonal bit, but also then there's the political parts of it. Recently, with issues that we've seen, would it have been better if we had more gas storage in our own country to look after ourselves for these hugely one-off critical events? So storage can serve, sort of a more market-driven approach, but also, is there other more strategic reasons to have more storage that provides you certain features and certain securities? I haven't got that answer, but I think my version is yes, but I'm probably saying yes today because I didn't know what happened yesterday. Maybe a year and a half ago, I might have said no. So I think it's, short-term issues and those things change our minds, and hopefully we can keep that clarity in place over the next few years.
Kirsty, what about storage investment?
Well, I mean, I think storage. I think there's a lot going on in the field. I wanted to pick up just on something that it sparked in my mind, which was the conversation yesterday about baseload. So the role of storage plus a set of other things that allow a more flexible and dynamic system to be operated. So I think it'll be really important for people in this room to help sharpen up how we understand that, because I've noticed there seems to be a sort of, revival of we need these things for baseload. I'm not talking about the point about, this winter, but I think the kind of analytical work that yourselves are able to bring to bear, and that's really helpful.
Okay, and a final question then. So imagine you're in charge of government and you have an opportunity to make a change tomorrow to improve our energy infrastructure in a strategic way. What would be your first change tomorrow as a person in charge?
Good to meet.
I'm not going first.
Obviously, maybe I would say build a hydrogen network, but let's take that back to somewhere else. So, I mean, Vandad mentioned it, and it's been mentioned a while, and just generally, what we struggle with today is making decisions today with that uncertainty for tomorrow. And I think it's uncertain what hydrogen networks need. It is uncertain what the electricity system looks like, and it's all uncertainty. But going back to Kirsty, at some point you need to make a decision on what that is, and at some point you're going to regret a decision, but maybe you'll regret not making a decision more so. So I would probably put in place somewhere you can make more upfront, strategic, future-proofing investments. Obviously, it needs to be justified at some level, but ultimately you don't have to have a massive, huge, robust, this is going to happen. You have to have, there's a possibility this is going to happen. And we think investing up front is the best option. So I think that would probably be my one policy change.
Just to add to that, we'll be potentially providing a platform, maybe remove the uncertainties, to be able to track long-term investment. I think a lot of the project we see, they've got either through they're market-driven, or the regulatory framework is so short-term that actually will give that investor potentially like a very negative view compared to say other sectors. So if you're investing in a motorway network on an airport, you can clearly see like the utilization, long-term security. Whereas, on a potentially grid project, energy project, it's such a short term, actually, in some of them, we probably need to have more of those things like CFD, for example, and for what other aspects of the energy market, I think, provide that. So.
Well, I'm tempted to sort of, get rid of great big swathes of decision making and just like really, have one big central focus around bringing all the right people into the room and doing things in a really straightforward, long-term way. Because there's a huge amount of interest in the energy transition and optimism about it in different places. And for some reason, we just need to have a much more consistent line of sight on what that can help us deliver. So it's not a sort of do this or do that, but just much more straightforward consistency that looks like we're serious about it. And, I have to say, I have on my phone the sort of NOAA app that shows parts per million and of CO2. And when I was born, parts per million were 320 parts per million. And this whole month, on the seasonal upswing last year, it crossed 420. And this whole month, it's been above 420 parts per million. So I don't think these things are clever ideas. They're about what are we going to do in a really straightforward way to deliver outcomes, because it's not just climate change above social things. This is about our collective interests and those of our friends around the world. And easy to say, hard to do, but we've got to be at the rewiring level of getting this done so that we create the conditions for scale. That's why I've got bogged down in decision infrastructure and analytics, not because it'll ever look fashionable, but because without that, I don't think we've got the conditions for scale, and that's what we need to focus on.
Wonderful. So Malcolm is going to invest the money, and then Vandad is going to check that money gets spent wisely, and Kirsty is going to rewire our decision-making process on where that money gets invested. So I think our panel members have covered a huge range of topics for us. It just remains for us to thank them in the usual manner.